Welcome to the Math Practice Standards webinar series. This webinar will provide you information on the 5th Mathematical Practice Standard, Use Appropriate Tools Strategically. Let's start by reading this Math Practice Standard in its entirety. Then we will unpack it piece by piece. Mathematically proficient students consider the available tools when solving a mathematical problem. These tools might include a pencil and paper, concrete models, a ruler, a protractor, a calculator, a spreadsheet, a computer algebra system, a statistical package, or dynamic geometry software. Proficient students are sufficiently familiar with tools appropriate for their grade or course to make decisions about when each of these tools might be helpful, recognizing both the insight to be gained and their limitations. For example, mathematically proficient high school students analyze graphs of functions and solutions generated using a graphing calculator. They detect possible errors by strategically using estimation and other mathematical knowledge. When making mathematical models, they know that technology can enable them to visualize the results of varying assumption, explore consequences, and compare predictions with data. Mathematically proficient students at various grade levels are able to identify relevant external mathematical resources, such as digital content located on a website, and use them to pose or solve problems. They are able to use technological tools to explore and deepen their understanding of concepts. As you can see, Math Practice 5 is calling for strategic use of tools and covers several habits that students should be proficient in. Let's break down each section so we can fully understand each of these proficiencies. The first statement in this practice demands that students know the appropriate tools and when they might be useful. They should recognize the gains and limitations of a tool, and proficient students always do the math, not letting the technology do it for them. The next section refers to proficiency with estimation. Students should be proficient in detecting errors by strategic use of estimation and their own knowledge of math. And the last part of the standard is about the mathematically proficient student having the ability to identify and use relevant tools and resources, such as technology, and recognize that resources help them to better understand a problem. Now that we've unpacked this mathematical practice, we'll discuss how to implement using appropriate tools strategically in the classroom. This will involve the necessary planning needed for authentic tasks and problems to be incorporated in the lesson design. Whether it's calculators, rulers, tape, markers, graph paper, two-way counters, or laptops, when a lesson design includes tools, a red flag goes up in a teacher's mind. Chaos is potentially imminent. So implementation of this practice begins with training the students. Math Practice 5 looks quite busy in the classroom. There is problem solving involving various tools, active students, and lengthy mathematical discussions. But the only way these activities will still be productive is through deliberate planning. Planning for the math practices means looking at the actual student experiences that will occur as you teach the concepts. It's about how the students will be learning the concept. What tools will be necessary for students to practice the task themselves? Will these tools be available for today's lesson only or become permanently accessible to the student? In order to achieve proficiency of Math Practice 5, using these tools should become habits of mind and part of the pedagogy of every K-12 mathematics teacher. It is important to consider what mathematicians refer to when they use the term tools. Tools are any object, picture, drawing, or figure that represents a mathematical concept used by students to make meaning of the mathematics, or on which the relationship for that mathematical concept can be imposed. Tools allow students to interactively reason and engage in discourse about mathematics, helping them to construct mathematical meanings and explain their ideas. According to NCTM, the National Council of Teachers of Mathematics, these tools should be used frequently with complex problems that require significant amount of effort. But how do we know that our students are developing the habits of mind that call for using appropriate tools strategically? Let's discuss the questions that we must pose of ourselves during the planning and implementation stage. We'll also cover the questions that we eventually expect our students to pose to themselves as they become proficient in this practice. As you design your student experiences, you should be constantly asking yourself if you are doing what it takes to create the essential habits of mind. Math Practice 5 needs tools. Questions we should ask ourselves are, did I select engaging problems and tasks that are made simpler using tools? Did I create the opportunity for the students to choose which tool they will use? I find that training the students how to use the tool properly and also pointing out non-examples of proper use of tools, such as sword fighting, is very effective. You know they know, but taking a moment to remind them of proper expectations is not a wasted moment. Some teachers like to assign roles, so the materials manager is responsible for returning the tools to their correct area. As you design your lessons, a quick rundown of these questions will lend itself to a better design. Do I model the use of appropriate tools when solving problems? Do I discuss why a particular tool was selected? Do I provide a variety of tools in which students can explore and practice using? Do I ask students which tools will be helpful in solving specific problems? And do I ensure my students know how to use tools correctly? As we get better at asking ourselves questions during planning, we need to train students to ask themselves questions too. Training should begin at a very young age and should create lifelong habits. As teachers, we should ask the students these questions as they are engaged in the tasks, but the emphasis is on the fact that we want them to develop the habit of asking themselves these questions. Which tool will help me solve the problem? Did I estimate first? Did I compare my answer to my estimate? Was that tool effective? Does my answer make sense? How do I know? How is my answer like others? Are there different ways to solve this? Now it's time to get more specific about the types of activities and tasks that it takes to provide the desired habits of mind for Math Practice 5. The key to a smooth lesson using tools should begin and end with your direct instruction. As you begin with the following activities, it is helpful that each of these items have been discussed. Students know what math tools are available. Students know when to use math tools. Students know how to use math tools, and students understand the tool's limitations. The what, when, and how will not just occur. It takes direction in the beginning. A simple tool that can be used in the classroom is a number line, whether it's a big one on the wall, a small one on the desk, or one that the student drew himself. How much more understanding would the students have when discussing range if they used a number line? Instead of biggest minus smallest procedural understanding, imagine being asked to count on a number line how far are they apart. Suddenly, range becomes clearer with the right tool. The number line is sometimes regarded just as a visual aid for children. It is, in fact, a sophisticated image used by many mathematicians. For young children, it helps develop early mental images of addition and subtraction that connect arithmetic with measurement. Rulers are just number lines built to spec. This number line image shows the distance from 12 to negative 12, or how much greater 12 is than negative 12. The next 3 slides will illustrate how the same basic scenario can be used in different grades. Notice how the tasks change and therefore how the tools used to determine the solutions change too. Here we are presented with a diagram that represents the following scenario. Sue is designing square swimming pools. Each pool had a square center that is the area of the water. She uses one color tile to represent the water. Around each pool there is a border. She uses another color of tiles to represent the border. Below are pictures of the 3 smallest pools that Sue designed. For each square pool, sort the tiles into tiles for the water and tiles for the border. Count how many tiles are in each pile. Which has more, the water or the border? Is that always going to be true? This is a K2 problem. Notice how the task asks for the simple tools to be tiles. In the higher grades, 3rd through 5th grade, the task may state this: build the first 3 pools and record the data in a table. Extend the table for the next 2 pools. If there are 32 border tiles, how many water tiles are there? How did you get your answer? If there are 36 water tiles, how many border tiles are there? How did you get your answer? Can you make a pool with 49 water tiles? Explain why or why not. The tool of choice for this problem is a chart or list or a data table. In secondary grades, the task may state this: what are the variables? What is changing? How are the variables related mathematically? Do these relationships describe any type of function? How do you know? Graph any functions that you found. Secondary tools become function tables and graphs. Notice how using a tool doesn't necessarily mean a ruler or concrete model. It is simply using something that will make the mathematical relationships easier to see and understand. This is another example of a high school math geometry problem. A kite maker manufactures quadrilateral kites. He can make any quadrilateral as long as it is a convex quadrilateral. You have been asked to give advice to the kite manufacturer. Every time an order comes in for a type of quadrilateral, square, rectangle, trapezoid, parallelogram, or rhombus, he needs to know what sticks to use and how should they be put together. He also wants you to create prototypes and present options to the manufacturer. Students are required to use models and reworking designs in order to solve. Students are given sticks and other mathematical tools, a compass, a protractor, rulers, patty paper, to work with in order to create prototypes and present options to the manufacturer. This task demonstrates perfect implementation of Math Practice 5 that we're talking about. Also, Math Practice 1, make sense of problems and persevere to solve them. And Math Practice 2, reason abstractly and quantitatively. It's not rare that one task can be used to implement multiple mathematical practices. In fact, it happens more often than not. And truth be told, this task could also be classified as a full-blown STEM activity. Now I want to revisit a problem that was used to demonstrate Math Practice 1 and Math Practice 2 and point out its connection with Math Practice 5. James went to the Boogie Ball. It was being held 15 miles from his home. He called the Orlando Diamond Cab Company for a ride to the venue. How much did his ride cost? Create an equation to represent his trip. Create an expression using M for miles to represent how much the Diamond Cab Company charges its passengers. The tool used in this problem is the Internet. Notice that the students must make sense of the problem and determine what numbers that they need to use to solve the problem. And where will they get them? A quick internet search finds the correct values. These questions are very engaging and offer other uses of the internet beyond games, videos, and Wikipedia. The next 2 slides will show some examples of how easy it is to create engaging problems where students' tool of choice is the computer. Morgan built a scaled model of the Sears Tower. The scale of the model is 1/2 inch equals 50 feet. How tall is Morgan's model? Students need to know the height of the Sears Tower, then convert it to feet. The Internet is the tool to locate the information needed. The average person burns 3.6 calories per minute when walking. How long will it take a person to burn off a Big Mac? Here, students use the Internet to find out how many calories are in the Big Mac. And trust me, you don't want to know the answer to this question. So we will now conclude this webinar with a quick discussion on how we would assess Math Practice 5. Students can be assessed informally during this process just by asking questions as you circulate. But some teachers may want a more formal rubric or checklist. This rubric can be used or adapted as a quick reference to assist with that assessment. Use appropriate tools strategically. Emerging students use the appropriate tool to find a solution. Proficient students select from a variety of tools the ones that can be used to solve a problem and explain their reasoning for the selection. And an exemplary student combines various tools to explore and solve a problem as well as justify their tool selection and problem solution. It may also be valuable to assess yourself. This rubric is a great planning tool as you design your lessons. As we become more self-aware of the environment we create, we should see a direct impact on the math practices or habits of minds of our students. As we conclude this webinar, consider planning tasks that require students to choose tools to help them find their solutions. Model for students how to best choose the tool and ensure that choice becomes a habit for them as they become mathematically proficient students. We hope this webinar helped clarify your understanding of Mathematical Practice 5, Use Appropriate Tools Strategically.